Hi, everyone. Very happy to be here today. My name is Barnhart-Magen. I'm a co-founder and CTO at Profero. Profero is an incident response company. As such, we help customers prepare for their next incident or when they actually have an incident. And in both cases, passwords are very close to our heart. Passwords are one of the most common attack vectors attackers use in order to gain access to systems. So LastPass Breach was close to heart for us. Sharon Brisnov, who collaborated with me on this research, is the director of research at Claroti, an OT company, and I'll mention later the parts that he took a deep dive into. We don't have a lot of time today, so for at least for some of the topics, I'll be skimming through them. But feel free to Q&A to get some answers from me during Q&A, or to reach out to me with my contact details, which I'll share at the end. Why should you listen to me? I have some experience in the password manager space. I designed password managers. I designed HSMs, or hardware security modules, which are basically hardware-based password managers, and also have a patent in the field. Why do we need password managers? So the best practice that we came to realize after many, many different instances in the past decades was that each service that you're using should have its own unique password. The reason for that is that if that service is compromised, you don't want attackers to get password from that service and use it on other services as well. However, getting to tens, hundreds, thousands of different passwords for different services is very complex. So we need a password managers to help us manage those passwords. We would like a password manager that would help us store our passwords in a secure way. Security is important to us. We use passwords. Also, provide us with a good user interface. So whenever I want to manipulate those passwords, replace them, add them, delete them, find them, it would be easy to do. But also with a good user experience. We want the password manager to proactively assist us. If you're on a web page that is asking for a password, we want the password manager to pop up and say, this is the password, we want me to autofill it for you, etc. So we expect a lot of things from this product, from this password manager. But that password manager is holding a lot of sensitive passwords or sensitive secrets like credit card numbers, etc. How would you protect all of them? The answer is very clear. You should encrypt them. But if you encrypt them, you still need a key to encrypt all of those passwords. And the way that you solve this chicken and egg problem is that you create a key based on a master password. So the assumption is that you have a very strong master password, and you generate a key, an encryption-decryption key from that master password, and you use that in order to decrypt or encrypt a database of unique passwords, so the password manager can then use that in order to interact with different services. LastPass disclosed the breach of their system in August 2022. Someone gained access to their cloud storage and stole vaults or databases belonging to their customers. And they had made some very interesting claims in their announcement. They said that since 2018, they require 12-character password minimum, which is good. And they use stronger than typical PKDF2 with 100,100 iterations. Not sure what this means. We'll explore that in a moment. And that they recommend never to reuse the master password anywhere else, which is a very good recommendation, and I endorse it. And furthermore, they said that in 2022, they learned that attackers had access to vaults, and they copied those vaults from the cloud backup they were stored on. However, customers are safe because LastPass is using a zero-knowledge architecture. Not very clear what zero-knowledge architecture means here, but the assumption is as long as the attackers don't have access to the master password, then the fact that they have the vault is not useful because they just have encrypted data. So that means that customers are safe and nobody needs to worry, just move along, everything's fine. Well, obviously, that's not the case. Let's explore why. First thing, PKDF2. PKDF, or password key derivation function, is basically a function that takes a user input on one end, your master password, and generate a key on the other end that can be used for encryption decryption using a mechanism called hashing and doing it again and again and again and again repeatedly. So a PKDF function, one of the parameters or one of the important parameters to the function is the number of iterations. If you have more iteration, that means that it takes longer or it's more computationally intensive to compute the hash or the series of hashes for that input. Until 2018, the requirement by LastPass was 5,000 iterations, and they upgraded it to 100,100 in 2018. So that's the current situation, and you should rest assured because everything is fine, except that the world keeps moving on. And the current best practice is something around 310,000 iterations. CPUs get better all the time. We have cloud compute today. We have more capabilities on attackers' hands that they didn't exist 5 years ago. And unfortunately, they did not upgrade their iterations above that. It is possible to manually go into the settings page and choose your own number of iterations, but I'll make a very easy assumption here is nobody ever heard of that setting and nobody ever went ahead and done that. Maybe, I don't know, a handful of people ever done. Best practices are important, but best practices change over time, and you need to make sure that whatever you're using is still using the current best practices and not whatever was best practice 5 years ago. However, users with accounts created prior to 2018 still use 5,000 iterations today. They never migrated or never upgraded the settings for those users. So those users are specifically are at enhanced risk because the attackers need to break 5,000 iteration, not 100,000 iteration. And obviously that's much easier. Sharon decided to run some tests to give you a better understanding of what are we talking about. So using a MacBook Pro laptop running Python without any kind of special optimizations, we can reach about 10 derivations per second. So if we need to find a password and assuming that we are using 100,100 iterations, it'll take us about 1/10 of a second to find it. However, if you want to do 10 passwords, it will take us about 1 second and so forth and so on. Assuming even if we had better CPUs or use a couple of different CPUs in parallel, using GPUs, better code, better assembly, etc., we can probably make this faster by 2 or 3 orders of magnitude. But still, this means it will take a very long time to crack passwords using that mechanism. It'll take years and years. Therefore, the announcement or the claim made by LastPass is that users are safe. The underlying assumption behind this calculation, which is true, the calculation is correct, is that an attacker needs to crack a password that is completely random and it is evenly distributed over the entire key space. In other words, assuming that every user is choosing a computer-generated random password of a very large size. And unfortunately, this is not the actual use case in the real world. But before we go into that, I want to explore 2 other pieces of data. Another thing that they said was zero knowledge, that they don't have access to the master password. Sharon and myself both asked the same question. Okay, so let's say that they don't have access to the encrypted values. Is there anything else that the attacker has access to? And the answer to that is pretty surprising because the database that they're using in the vault only encrypts some of the columns, not all of the columns. That means that an attacker has access to data even if he does not have the master password to decrypt everything. And the data that he has access to is very interesting. The first thing that he has access to is what services you're using. Are you using Facebook, Instagram, TikTok, or whatever? If you store the password, the name of the vendor will be in that database. And that's very interesting to attackers because it's very easy to build a phishing email to you. Because if you're a user of, I don't know, of TikTok, you can get now an email from TikTok saying, hi, this is TikTok. We know that LastPass had a breach and you're a user. Please make sure that you replace your password. Here, this is the link to replace it. But more than that, or more interestingly than that, they store URLs in the database and they store them unencrypted. So why is that important? Assume this scenario. Let's say that you wanted to reset one of your passwords because you forgot it. So what usually happens, you click the forgot my password link, you get an email, you click the link on the email, you go back to the browser, and now the browser is asking you, please select a new password, you type it again, and you click save. Usually at that point, the password manager will pop up and ask you, do you want to save this password? And you will click yes, because it's a new password, you want to save it. And at that point, the LastPass password manager will also save the URL on the web page that you used in order to reset your password. So the reason this is interesting or dangerous is because usually these URLs contain reset tokens. And on some systems, you can still use those reset tokens weeks or months after they were originally generated. That means that the attacker can take a look at the database, find those reset tokens, and reset passwords to your services without actually knowing the master password or the password itself, just by using that URL. Again, very dangerous. So we created, or Sharon created a LastPass account and created a vault and wanted to look into it and see what kind of data is accessible. So just by looking at the data, you can see that it's not encrypted. There are readily apparent patterns to the data right here. So there are easily available parser others on GitHub and other places. And the LastPass vault is basically an SQLite database with encrypted values. So the columns that they are encrypting are marked here in green: name, folder, username, password, etc. And they're actually encrypting them, so you won't be able to find the value for the username or for the notes or everything else. So that's fine. But all of the other information here is not encrypted. And there's a trove of information you can use here. What kind of information you're using, what kind of password you're using, what URLs you have, when did you last change your password, any other form fields like hints provided, stuff like that. They are all unencrypted in the vault. So we wanted to also run a simple test on the encryption on the vault, and we saw that the encryption for those fields is probably fine. We don't see a problem with the encryption itself, but all of the other information is not. Back to the assumption. As I mentioned previously, all of those numbers that LastPass shared, it'll take years and years to crack the passwords, or even all of those, I don't know, guides you see online with nice colors. If you have a 6-character password, it'll take this years to break. If you have an 8-character, it'll take that years to break, etc. They're all based on very sound math that is very irrelevant to the real world. In the real world, attackers are not trying every possible password. What attackers are doing, they take a list of known passwords and permutations on those known passwords, and they just try those first. So instead of guessing every possible password, they will try first guessing all of the common passwords. For example, this rocky.txt file, which is very common, has about 14 million different passwords. And you would be very smart to first try those 14 million passwords. You will probably be correct around 80% of the time, and you will find your password here. So going back to their claim of a 12-character minimum, again, sounds like a lot. But again, it's not really a lot because it's not 2 to the power 72. It's more like 2 to the power 35 for many different reasons. But to give you a better idea of what this means practically, that 2 to the power 35 guesses will take about $100 to crack and a couple of hours. That's not a lot. Assume the following scenario. You go over all of the vaults. You're an attacker. You go over all of the vaults you've stolen, and you pick, I don't know, 10 different users who have credentials to their Chase or to their, I don't know, whatever bank account in those vaults. And you just focus on those 10 users, and you pay $1,000 in order to crack those passwords. Would you be able to steal more than $1,000 if you have credentials to the bank accounts of those 10 people? Probably yes, and that's worthwhile to the attackers. The other thing is that the 12-character minimum was introduced in 2018, but users prior to that period don't have that enforced. That means that if you created an older account and you had 6-character password, that's fine. And the attackers don't need to wait that long in order to guess 6-character passwords. That's trivial on today's hardware. So the attackers have at least a subset of the users with very weak security parameters, and also all of the others. So what went wrong here? The first thing is, from my own perspective, is they had weak settings. They knew that they had weak settings, but they did not migrate the users from the older, weaker settings to the new best practiced settings. And I assume, and I'm pretty much aware how it works, there are always product decisions. Maybe it will bother the customers. Maybe it will take more time to develop. Maybe it's very difficult to test it. I don't know the reasons. But the bottom line is that we are now in 2023, 5 years later, and there are still users with very weak parameters in the system. and the attackers who are going to attack or target those specific vaults will be able to crack them very easily. And that is deterrent to a security product claims for security. Also, they stored a lot of pretty important information in clear text, and I understand why they did it, because that brings a good UI and a good experience. When you're searching, you can search in clear text fields. You don't need to decrypt it in order to read it. It makes everything faster and nicer, but the security is much, much weaker. And the last thing, they did not really disclose how the attackers got to their backups. Why weren't the backups properly protected? Why weren't the backups encrypted? So that's not clear at this time as well. But as Billy Mays says, but wait, there's more. So 2 days ago, 26th February, they had another announcement. Released 28th February. They had another announcement, and that is that users of LastPass using the SSO feature, meaning the federated authentication with a third party like Office 365 or Okta or something else, also have a possible problem. And when they're talking about the SSO users, they split the secret into two parts. The K2 part, which is coming from users typing in their master passwords, and the K1, which is coming from the integration with that vendor. So what happened was that all of those K2 values coming from the users were kept in LastPass database encrypted, but the attackers stole those vaults with those encrypted values. And in order to decrypt them, they specifically targeted one of the members on the LastPass DevOps team in order to get the credentials to decrypt all of the K2 values. And they successfully done that. So now they have all of the K2 values. Now they need the K1 value in order to get the master passwords for all of those vaults in the organization. And the K1 value is not unique per user, it's unique per organization. That means they just need to compromise a single user in that organization, get the K1 value out of it, and now they can access all of the vaults in that organization. So you would say, okay, getting the K1 value still requires work. How would they know who to target? Well, they stole all of the vaults, and the vaults have in clear text in them which organization you belong to. So that means that they know who to target. They know that if they'll spend their money, they'll have access to all of the keys in that vault. And they already made the effort to target a specific individual on the LastPass team. So I would guess that they know exactly what they're doing, and it's a very targeted attack to get into some high value target information. So what can you do? First thing is, it's much better to use a password manager than not using a password manager. But when you do use a password manager, try to get multi-factor authentication on every account that you can. If it supports multi-factor authentication, use it. That is another high bar to jump over for attackers. If a service offers a multi-factor authentication, it just offers SMS, use that. If it offers using a TOTP, the QR code, use that, that's better. If it offers using a hardware security token and you have that, that's even better. So try to use the best security that you can and integrate it into your password manager. For high security accounts, I recommend to separate your multi-factor authentication into a separate program, not to store your multi-factor authentication inside the password manager. Use something else, like an application on your phone or something similar. And lastly, choose a very strong master password to protect your secrets. I suggest 3 different ways to choose a very strong password. The first one is just choose a random password and memorize it. It's an effort, and it's probably the strongest route to take, but it's not easy. The second thing is what XKCD offered, Randall Munroe offered, which is choose 5 to 7 random words, construct a sentence out of them, and use that sentence. Pick a book, flip pages, select words at random, write them down. Now you have 7 different words. That's a very strong password. Lastly, if you're bilingual, take advantage of that. Think of some phrase in your native tongue, convert it using the English keyboard, and use that in order to log into whatever you need for your master password needs. With that, I'd like to thank you. If you have any questions, I'll be around for the Q&A. And if not, you can use my contact details and reach out to me directly. Email, Twitter, LinkedIn, whatever you feel comfortable with. Thank you very much.